Hi learners, welcome to AI modules. We have a lot of modules over here in the data science, computer vision and natural language processing. You could explore all these models as per your convenience. Today we would learn about heart attack prediction. You have models right from basic to intermediate and finally advanced. As part of data science, we would consider heart attack prediction today. If you are here, you might have already covered the data science portion and watched those videos. You understand supervised and unsupervised learning. And here we are going with heart attack prediction. Heart attack prediction is a beautiful model where, given the data, certain parameters, you could predict whether the person is prone to heart attack or heart disease or not. Okay. Here we are talking about healthcare industry. This is a very important parameter over there. So you could predict the health of or future health of a patient depending upon the current data or the past data. So this is how the healthcare industry works, where you get data from different sources and different patients in the past, and then use it to predict the diagnosis of a patient right now. So the objective of the model is to predict probability of getting heart disease in the near future using the classification technique. So we are using a classification technique over here. We did in the lip pass. It is a data science model and it is an advanced model. Here we are talking about Cleveland heart disease data set. It is a repository. It's a very good data set, and data scientists, whenever you're learning, you will invariably go through this. And you have so many variables: age, sex, chest pain, resting blood pressure. These are all medical terms, but you need to just go along with what they want and how they want. We have given the description here. It's not like you will enter values where sometimes you select the values. So mind these when you are inputting data. So it is in the some are categorical format, some are numerical format you can give. And we follow a 5-stage method approach. So we have 5 stages over here. You will go through each stage and perform your learning. Data source, you get the data in the right format and right type, relevant data. That's what it all meant about. Then EDA and feature engineering. Here we are talking about finding the interdependencies of the variables, which variable have a more predictive power, and then feature engineering, feature extraction, so that your data gets more predictability power when you go with the model training. Algorithm selection, as we always mention, you can select the right algorithm. That is the most important thing, whether it's classification or regression, whatever it is, you need to select the right algorithm. Sometimes you get more than one options. That's the trick over here. Maybe sometimes you need to do iterations and find out this model is good or this algorithm is good, and then proceed with that. Model optimization, it is nothing but a parameter tuning, or you call it hyperparameter tuning or optimization. Here you give the right parameters so that your accuracy is high and then predictability is good. So you could deploy it finally, and then the user will use it, whether it's on web or cloud computing. You could do that, or on a standalone system. So you go through this documentation. We are defining the introduction, data sourcing, model building, and then for everything we have a code over here. It takes time for you to go through this data validation. How are we doing the validation? And finally deploying the data. We will give you the code. So moving on to the data sourcing step, here we have, you could see much data over here with the target variable. So it is a supervised learning, whether the person will have heart disease or not. It is defined over here. I dare to go there, say 0 and 1. So it is predicting, it's a target variable, supervised learning for all this historical data. Once you go through the data, move on with model building. Here you have multiple options: train, test, set, and random classifier. For random classifier, you could use so many parameters over here. Going to selecting parameter, you could see the scikit-learn syntax for this algorithm. You have random forest classifier, estimators, maximum depth, criterion, minimum samples, all those things you can read. The documentation is very good, and you must go through this if you want to learn about data science properly. It's not just using the algorithm and what it says and how you can manipulate it. That is more important. Don't just use it and leave it, but learn properly. So if you're not sure what to do, reset it and then go for check accuracy, and you will get a accuracy for the given hyperparameters is 81.1%, which I'm very much happy with that for the training sake. And confusion matrix, it defines how your classifier is working. So this is fine with that accuracy, and I could do better. But anyway, for the training sake, we'll move on. We have then go data validation. Here I could literally behave like a user. I change my value parameters and then see how my model is working. And then I go with gender, change it here, and chest pain, blood pressure. Always remember to go ahead with whatever is a classic categorical data. So I select the categorical data, and resting blood pressure, whatever I need to know, you will have the information over here. Read through the information and select the right parameters. It's advanced model, so you get more parameters to choose. And then once I'm ready, I predict my thing that given the input, I have high chances of getting heart disease. Probability stands at 50%, but it is high chances, so I should be careful if I'm this person. Okay, so this is how, depending on your vitals, the parameters, you could predict whether a person gets heart disease or prone to heart disease or not, and so that medical action could be taken. And finally, we have deployment over here. We have with multiple options. We have GitHub, we have Jupyter Notebook, PDF, and Python, whichever you please. You could select. Now Jupyter Notebook, if I go ahead, I got my IPYNB file, that is Jupyter Notebook file. I could directly take it to Jupyter Notebook and start coding using the code, or I could use this code and change it, modify it to solve another problem whenever there is a prediction with multiple variables. This is how we encourage you to learn, use the code and solve real problems. That's how you learn data science properly.